Hi there, so welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 56. We are on Introduction to Data Visualization with Seaborn, so which is the Python powerful library that makes it easy to create informative and attractive data visualization, which is Seaborn. So we are on the third chapter, and we are going to be learning how to visualize a categorical and a quantitative variable in this lesson. So we finished chapter 1 and chapter 2 of this course on day 53, 54, and 55. You get that now. So we started learning from introduction to Python. So if you're interested in learning Python over a couple of days, I will encourage you to go to Python day 1 on the live stream tab on the channel. And I'm going to see everything for basic of Python till where we are today. And we started with SQL also and Power BI. You can catch all of that on the live stream tab on the channel if you're looking to learn how all these technical how to's as a data analyst or professional. So I'll just start sharing my screen so we can go back to our learning ASAP. So welcome back. So every data sets, Python files that we'll be using over the course of this lesson, there's a link under the YouTube description. You can see my Python for data analysis, all of them, all the way from introduction to Python. Let me just zoom in a little bit. Yep. So all the way from introduction to Python, we've covered introduction to Python, intermediate Python. We did our first project, which is investigating Netflix movies in Python, data manipulation with pandas, this is exploring NYC public school texts. So this is another project. Then we did learning data with pandas in Python, introduction to statistics in Python, and intro to data visualization, which is we're on the 8th course so far. So that's what we've done over the couple of lives, over the last 56 days of learning. So I just go ahead and go to career track section. And so we've actually completed data analysis in SQL and data analysis in Power BI. So if you're looking to upskill yourself in these two tools, just go to the live stream tab on the channel. You're going to see all the lessons, all the live streams there. So let's continue with the data analysis with Python. So this is where we stop. So we are moving to visualizing a categorical and quantitative variables, so it says categorical variables are present in nearly every data set, but they are especially prominent in survey data. So in this chapter, you will learn how to create and customize categorical plots such as box plots, bar plots, count plots, and point plots. Along the way, you will explore every survey data from young people about their interests, students about their study habit, and adult men about their feelings about our masculinity. So let's see what we can learn. Probably we'll just take a couple of lessons and continue tomorrow, day 57. So I think I have the data set here. This data set called Young People Survey. This is a survey data set. We also work with this student alcohol consumption data sets, these countries and MPD. So we have these two data sets we work with, which I will link under the YouTube description. So you can also download the data sets and practice yourself also. So let's start. I'll just check.
Welcome to Chapter 3. In this chapter, we'll focus on visualizations that involve categorical variables. The first two plots we'll look at are count plots and bar plots. Count plots and bar plots are two types of visualizations that Seaborn calls categorical plots. Categorical plots involve a categorical variable, which is a variable that consists of a fixed, typically small number of possible values or categories. These types of plots are commonly used when we want to make comparisons between different groups. We began to explore categorical plots in Chapter 1 with count plots. As a reminder, a count plot displays the number of observations in each category. We saw several examples of count plots in earlier chapters. like the number of men reporting that they feel masculine. Most men surveyed here feel somewhat or very masculine. Just like we used rel-plot to create different types of relational plots, in this chapter we'll be using cat-plot to create different types of categorical plots. Cat-plot offers the same flexibility that rel-plot does, which means it will be easy to create subplots if we need to using the same col and row parameters. To see how cat-plot works, let's return to the masculinity count plot. On the left, we see how we originally created a count plot with the count plot function. To make this plot with cat plot instead, we change the function name to catplot and use the kind parameter to specify what kind of categorical plot to use. In this case, we'll set kind equal to the word count. Sometimes there is a specific ordering of categories that makes sense for these plots. In this case, it makes more sense for the categories to be in order from not masculine to very masculine. To change the order of the categories, create a list of category values in the order that you want them to appear, and then use the order parameter. This works for all types of categorical plots, not just count plots. Bar plots look similar to count plots, but instead of the count of observations in each category, they show the mean of a quantitative variable among observations in each category. This bar plot uses the tips dataset and shows us the average bill paid among people who visited the restaurant on each day of the week. From this, we can see that the average bill is slightly higher on the weekends. To create this bar plot, we use catplot. Specify the categorical variable day on the x-axis and the quantitative variable total bill on the y-axis, and set the kind parameter equal to bar. Notice also that Seaborn automatically shows 95% confidence intervals for these means. Just like with line plots, these confidence intervals show us the level of uncertainty we have about these estimates. Assuming our data is a random sample of some population, we can be 95% sure that the true population mean in each group lies within the confidence interval shown. If we want to turn off these confidence intervals, we can do this by setting the CI parameter equal to none, just like we did with line plots. Finally, you can also change the orientation of the bars in bar plots and count plots by switching the x and y parameters. However, it is fairly common practice to put the categorical variable on the x-axis. We'll introduce more types of categorical plots later in the chapter, but for now, let's practice what we've learned.
Okay, so we're going to read the instructions and practice in this interface. But I always love to have my own practice here also in my Jupyter notebook on my computer. Let's just zoom in a little bit. I think that's great. So I'm definitely going to create my notebook real quick there. Let's create a new notebook. Uh, New notebook. While that is coming up, so I'm going to name. So I'm going to name this chapter 3, visualizing categorical and quantitative variable. I see this one was visualizing two quantitative variables. So this one will be renamed to, where is the name editor? Okay. Visualizing cuts. So let's rename that. So I also always like to copy all these libraries because we've learned all about these libraries. So I just run the code. So let's read the instruction and see. So in this exercise, we will return to exploring our data set that contains the responses to a survey sent out to young people. We may suspect we may suspect that young people spend a lot of time on the internet, absolutely. But how much do they report using the internet each day? Let's use a count plot to break down the number of survey responses in each category and then explore whether it changes based on age. As a reminder, to create a count plot, we use the cat plot function and specify the name of the categorical variable to count X, the pandas data frame to use the data, and the type of plots, which is kind. Okay, that's good. Seaborn has been imported as SNS and matplotlib.pyplot has been imported as PLT. So you said we should use our class plot to create a count plot using the survey data frame with internet usage on the x-axis. So we have the survey data here. All I have to do is just connect the survey data, which is this young people survey response. We're going to copy this line of code here to read the data sets from my local computer, which is young people survey responses. Young people survey responses. Let me just check that. So let's run that line of code. Oh, I have to change this to YPL. Let me just use YPL. So if I call on YPL now, I should have, you can see, voila. You can see the results here. Let me just zoom out a little bit. You see, these are the survey responses. So let's read this. You can see the gender right here. Whether they have the number of siblings, the age, the finances, the internet usage, and so a lot of data here. Let us just continue from here. So let's create a count plot. Let's create a count plot rather using this SNS cat plot. I'm just going to say SNS dot cat plots open bracket. So our x-axis is going to be is going to be internet usage. So we have x-axis right here. So we have internet usage. This column right here. That is our x-axis. So what will be our y-axis? So definitely, probably our y-axis is going to be by what? Let's see. So they need to specify what our y-axis is going to be. That is a problem. But we know our data frame here is called survey data. Data is called survey data here. And the type of plots we want to have is a count plot. I need to provide a variable for my y-axis. Let's see what we can pick up from here. It says, let's use a count plot to break down the number of survey response in each category and explore whether it changes based on age. Okay, that will be age. I guess it's going to be age. That will be the age of each individual. Let me use age there and run the code. Hmm. Okay, let me just take a look at the data set again. I could just use, let's get help. Oh, this is what I'm just supposed to do. Interesting. Oh, that's funny. So you said the error message indicate that there's a problem with the parameter you're using. So for the kind plot, you only need x-axis and the data. So the kind is equal to count. So I'm going to specify the kind there. The kind is now count. Voila, so we have a better view now. So this is what we need to do here. You can see few hours a day, most of the days. We can see it pretty well here. So I'm going to just copy this line of code and show you better in Jupyter Notebook here. So for our data is going to be YPR. Let's call it survey data. Let me just say YPR there. YPR. And let's run the line of codes. Voila. Oh, the category is not showing very well. Few hours of the day, the survey data says most people use the internet few hours of the day. It's a most of the day, more than an hour of the day, daytime at all. Okay, which is the internet usage. We have few hours a day, most of the day, less than an hour a day. Interesting. So you can see few hours of the day is the correct, is the highest categorical variable there. Let's submit and see. Make the bars horizontal instead of vertical. Okay, so we need to make the bars horizontal. Hold on a minute there. So once we make the bars horizontal, we just switch the axis. Hold on a minute there. For the bar to be vertical, if I say y-axis here, if I change it to y, let's see, let's run the code and see. Well, I can see they're now vertical. Few hours a day, most of the day, less than an hour a day, no time at all. Interesting. Now let's try the same thing right here. Our data is now going to be YPR. YPR. Then we run the code. Oh, like we can see it better now. Interesting. So those that use the internet few hours of a day are higher. That means nobody even says I don't use the internet at all. Interesting. So we all use the internet, and I'm currently using the internet right now. That's fantastic. So let's continue. It says separate these plots into two side-by-side column subplots based on age category, which separate respondents into those that are younger than 21 versus 21 and older. Ooh, how do that? We're going to use what is called. We're going to create definitely I'm going to create a list, a data category. So I'll just go up here and create age category. So it's going to be age underscore category for this to work. It's going to be a list. Just a simple list. Younger than 21. Younger than 21, comma, 21 and older. Then I could just come down here to my plot and just add an order to the line of code. So order is going to be age category. I just point to age category. S1. Ooh, not showing very well. Hmm. What are we missing here? Yeah, something is missing. Can you specify there's supposed to be a column argument there. Let's check. Let's get help. So all I have to do just mention co-category. So probably I didn't need to use the oh. But funny enough, we really have age. Oh yeah, not age category. Age, not age category. So I'm using age here. Let's see this. Okay, let's say co. Voila. Oh, I do have my age category in quotes. Let's see. Oh, you can see that means there is a what? Hold on first. Let me try it first here. There's a list already somewhere. So let me copy this line of code and try it in my Jupyter notebook here. Let's go on. You see? Let's say YPL for our data set here. Oh, you can see it's saying append the data. As there's no column for each category. What if I now make use of this here? Let's see. It's telling me this a wrong what? Wrong syntax for that age category. Can't I create my okay? Let's see now. I'm still getting the same error. Why now? This is a list here with the age category. Okay. So what can we do? So I'm looking for what we can do to make it easier. So I'm going to do this myself here in Jupyter Notebook. Let's give it a shot. Let's give it a shot. I want to try and recreate same thing in Jupyter Notebook, and if I don't get it, I don't want to move forward. Also done a second. Okay. So I'm trying to troubleshoot and get help for this. So we sort it out. So we're definitely going to be creating a list of each category. This is definitely going to be in quotes. So you see again that it's not seeing the column category. What if we add a column order? Let's see. Let me copy this error and try to troubleshoot it in. Just hold on a second there. So we're having this error because there's no this each category column in data set. So the other option that you could do is to create a new age category inside a data set, which is not what we want to do. We don't want to create a new column in the data set. Say separate this plot into two side by side column subplot based on each category. It separates. That means there's an each category column in the data set that was listed here. But I don't have each category. Let me double check. Hold on a minute. Internet age. I will just use the age only. Let's say there's any other information here. Let me now say age. Let me make use of age. Let's see. Wow. I broke it down into multiple age groups. You can see that we have here the age column 2019, which is not fair. Unless I zoom in before you can see this very, very well. You can see it broke the data set into multiple age group, which is not what we want, which is not what we actually want, which is not what we want. So what can I do? What can I do? I can create a new column that picks. Let me give this a shot. Let me create a new column in my own Jupyter notebook here called age category based on this age column. Let's create our own age category in this instance since we don't have a column called age category here. That will be easier for me to use rather than using this age column that is separating the data set into multiple count plots. I'll just add a new cell just below here. Let's create the age category column. I'm going to be using the data, which is our data is called YPL in this instance. YPL. So it's going to look at the YPL data. So you're going to say creating the age category column, YPL category equals to YPL age dot apply. So younger than 21 if age is less than 21. Else, let's run the code and see. Voila. So if I call on the YPL data now, I could just create a new YPL. dot edge. Let me just click on the a couple of rows there. You can see we have each category right here. As you can see, voila. Lots of my camera can see. So based on the age record there, this is younger than 21, younger than 21. So now we can now create our own data set here. This should give us a better result now. But let's see. Ooh, oh, I'm still using age, so I'm supposed to using age category now. Age category. Okay, let's see. Better. So this is what we needed to achieve. You can see. So we just we categorize our data. Say age category younger than 21, 21 and older. You can see the internet usage of different people within these age brackets. Whoa, that took a couple of minutes there, but glad we were able to solve it. Good job. It looks like most young people use the internet for a few hours every day, regardless of their age. You can see. So most young people use the internet for a few hours a day, regardless of their age. Yeah, interesting. Great. So let's continue. So let's look at one more challenge here. Oh, bar plot with percentages and customizing bar plots. So let's do this last two challenge so you can be done for the day. So let's continue exploring the responses to a survey sent out to young people. The variable interested in maths is 2. We have a column called interested in maths. Okay, this is mathematics. Let's not read the data. So the variable interested in maths is true if the person reported being interested or very interested in mathematics, and false otherwise. What percentage of young people report being interested in maths? And does this vary based on gender? Let's use a bar plot to find out. As a reminder, we'll create a bar plot using the cat plot function, providing the name of the categorical variable to put on the x-axis, the name of the quantitative variable to summarize on the y-axis, the pandas data frame to use, and the type of categorical plot, which is a kind. The kind. So use the survey data frame to create a bar plot with gender on the x-axis and interested in math on the y-axis. Interesting. Let's create this. I want to create a bar plot rather. So it's going to be SNS dot path plots equals to, so our x-axis, y-axis is going to be interested in maths. I'm just going to copy that real quick. Then our data frame is going to be survey data here. The type of plot we want to plot is called a bar plot. So let's see the results. Oh, what do you mean gender is invalid syntax? So let's get help on the error. Gender. Oh, that was my mistake. Okay. I was putting equals to the instead of parentheses. Interesting. You can see I mean, there are more males interested in mathematics than females. Okay, let's see. Let's see the same thing right here. So I'm going to change my data here to YPL. Oh, my mathematics there is just mathematics. And my gender here, do I have a gender column here? Gender, so we have a gender column there. So here is going to be mathematics, rather interested in maths. Mathematics. But like I can see, we have the same results. So mathematics, so there are more males interested in mathematics than females. So excellent. When the y variable is true or false, bar plots show the percentage of response reporting true. This plot shows us that males report a much higher interest in maths compared to females. Interesting. You could say the male students show more interest in maths compared to the female students. Interesting. So we are back. We actually took a break. Let's go for 30 days and complete. So we can complete our Python lesson. Not for now. So let's continue. So let's say customizing bar plot. Let's customize our bar plots and be done with today's lesson. So we're going to continue from box plots tomorrow. So in this exercise, we will explore data from students in secondary school, the study time, variable records. Variable record each student reported weekly study time as one of the following categories: less than 2 hours, 2 hours, 2 to 5 hours, 5 to 10 hours, or 10 hours, greater than 10 hours. The student who report higher amounts of studying tend to get better final grades. Let's compare the average final grade among students in each category using a bar plot. Okay, so I'm going to create a bar plot. Do you have access to the data sets? I doubt. Let me see. Student alcohol consumption, young people survey. I don't have access to the data sets. Oh, that's not bad. So we're going to do this one in this environment alone. And I'm going to practice this in my Jupyter notebook. SNS dot cast plots dot cats. So study time on the x-axis, our x-axis is going to be study time. Our y-axis, y-axis going to be the final grade is G3. This is student's data frame. So our data frame for this is the student's data frame. Do we have access to that data frame? We do not. Then our kind is going to be bar or common. Cat plots. Oh, I made a couple of mistakes. Voila. Look at the grades. Does that mean those that study more have higher grades? Or probably those that study between 5 to 10 hours, and those that study greater than 10 hours probably have the same grades. Let's see. So it now says using the order parameter and the category order list that is provided, we arrange the bars so that they are in order from lowest study time to highest. Okay, let's say arrange so that they are from the lowest study time to the highest. Okay, So this is the category order. Lowest study time, okay, less than 2 hours, 5 hours, 5 to 10 hours, greater than 10 hours. Okay, less than 2 to 5, 5 to 10. So the final line that we use there is the order line of code is going to be category order right here. So this is from the lowest study time to the highest study time. So those that are 5 to 10 hours tend to have higher grades compared to those that study uh greater than 10 hours, but we don't know yet. Let's see. Update the plot so that it's no longer display confidence level intervals. I'm going to say the confidence level intervals. I'm going to send it to none, which is the CI. CI is going to be set to none. Voila. These are so close, but we know that grades for students in our sample who studied more have a slightly higher average grade, but it is not a strong relationship. You could see those that study more have a slightly higher average grade, but there's no much difference. Interesting. Wow, this will be all for today. We've covered a couple of lessons using card plots, and we also look at how to bar plot with percentages and how to customize bar plots and change the orientation. So that will be the end of the live stream for today. So if you found value in this learning journey of Python with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button. I will see you on the next video on the channel. I'll see you tomorrow, day 57, as we continue to complete our Python learning journey. Bye for now.